This is lesson 9.2, solve quadratic equations by completing the square. The learning objectives are to complete the square of a binomial expression, solve quadratic equations of the form x squared plus bx plus c equals 0 by completing the square, and solve quadratic equations of the form ax squared plus bx plus c equals 0 by completing the square. And you have been working on solving quadratic equations. Back in chapter 6, you learned how to solve quadratic equations by factoring. Now, in this last lesson, 9.1, you learn how to solve quadratic equations using the square root property. And today, we're going to learn how to solve quadratic equations by completing the square. And what is a quadratic equation? Well, it's an equation that has the highest power of the variable as 2, right? Like x squared, when you see x squared as the highest power of the variable x, that's a dead giveaway that you're dealing with a quadratic expression or equation if there's an equal sign. Great. Something to remind you about to help us with today's lesson is that we have a binomial square pattern. If a and b are real numbers, then a plus b, that binomial, when you square it, it expands to a perfect square trinomial, a squared plus 2 times a times b plus b squared, right? And opposite version, right? Instead of a plus b, if I have a minus b squared, then that expands when I FOIL it to a squared minus 2 times a times b plus b squared. Okay, so we have uh, a binomial squared where we have addition between the two terms, and a binomial squared where we have subtraction between two terms, and they expand to a perfect square trinomial. Sometimes we want to, take a perfect square trinomial and factor it backwards, right? So factoring would be going from right to left. Great. Now, let's talk about this process of completing the square. So how do you complete a square of a quadratic that looks like this, x squared plus bx? Step one, identify b, the coefficient of the linear term x. Okay, so we want to identify b. We want to see if it's positive or negative, so look at the sign in front of it. Step two, find b divided by 2 squared, the number to complete the square. Step 3, add the b divided by 2 squared to x squared plus bx. So we're going to add it to the end of that expression. We'll just add it onto the end. And then step 4, factor the perfect square trinomial, writing it as a binomial squared. I'm going to walk you through this 4-step process of completing the square 3 times. Here, here, and here. So in example 9.11, we're asked to complete the square to make a perfect square trinomial, then write the result as a binomial squared. So everybody, this coefficient that goes with the variable x, x to the first power, see, that is the b value, and it's negative 26. Always pay attention to the sign in front. That is the b value. Okay, so I have completed step 1, which is to identify the b value, negative 26. Great. Step 2 is to find b divided by 2 squared. So take b, negative 26, divide it by 2 and square it. All right, I can do that. So I'll write it on the side here, negative 26 divided by 2 squared, like this. And, well, negative 6 divided by 2 is negative 13, and negative 13 squared is 169. Great. So no matter what the b value is, take that b value, divide it by 2, and square it, and that's the number to complete the square. Now step 3 is added on to the other stuff that you had. So I already had the x squared minus 26x, and so I'm going to rewrite that stuff. And I'll get x squared minus 26x, and then I'm adding on the value I got, right? B divided by 2 squared, 169. Awesome. Step 4, factor the perfect square trinomial, writing it as a binomial squared, okay? So this is a perfect square trinomial, and I can write it in this form right here, a binomial squared. And so I'll do that. And so I write it as, well, x minus 13 squared. And you may be asking, where did I get that minus 13? Well, negative 26 divided by 2, okay, is negative 13. So whatever my b value divided by 2 is, that goes in the binomial that I have. And because I have this minus sign right here in this perfect square trinomial, see that minus sign? Well, that's how I knew that I would have a minus sign in my binomial that is being squared. Great, let's try this process again, maybe with a slightly smaller number. Okay, so now I look at y squared minus 9 times y, and I ask, what is the b value? And that is the value, the coefficient with the linear term y, and that's negative 9. So I take my b value of negative 9, and I divide it by 2, and I square it. That's how I complete the square. See, b divided by 2 squared. This is the number to complete the square. Now, not negative 9 divided by 2, well, that's a fraction that can't simplify to an integer. I'm going to square it. So when you square a fraction, square the top, square the bottom, and you would agree that the answer is 81 over 4. Okay, 9 squared is 81, 2 squared is 4, and when you take a negative value and you multiply it by itself, it becomes positive, no more negative. I have just completed the square, and I will take that value of completing the square, and I will add it to the end of this stuff right here, right? So I just take that stuff and I add it to the end. That's what it says in step 3. Great. Now, this is a perfect square trinomial, and I can write this perfect square trinomial as a binomial squared. And so I take the variable y, and I'm subtracting. Why am I subtracting? Because of this minus sign right here. Okay, that carries down into the binomial. And now I think this guy right here, 9 halves, it goes right here. So I take 9 divided by 2, and then I square that. And this is the factored version of the perfect square trinomial. It's this binomial squared. Once again, how am I getting these values here? Well, I'm taking b divided by 2. The answer is always b divided by 2 for this. And here I got b divided by 2, and it went right here. Great. Let's try another one. And this is n squared plus 1/2 times n. And what is the b value? The b value in this case is 1/2. Okay, so I'm taking the b value. It's 1/2. And I'm dividing that b value by 2. And I'm squaring it. Right? So in step 1, I identified the b value, 1/2. It goes with the linear term. Okay, now I took b divided by 2 and I squared it. 1/2 divided by 2 squared. Okay, what is that result? Well, 1/2 divided by 2 is 1/4. And 1/4 squared, let me write that for you. 1/4 squared is 1/16. Because 1 squared is 1 and 4 squared is 16. So that's how I got it. And so now rewriting n squared plus 1/2 n, I'm now going to add on the completion of the square. That's step 3. Add the b divided by 2 squared value to the end of x squared plus bx. Okay, or in this case, the variable's n squared plus 1/2 n, add on the completion of the square. And then to finish, we're going to write this as a binomial squared because it's a perfect square trinomial. So I'm going to take a binomial and square it. And inside of that binomial, I will have n plus, and I take the b value divided by 2, which was 1/2 divided by 2, which gives me 1/4. And that's what I put right here. Great. We have just worked on completing the square 3 times. Okay, in 3 different cases. We even handled it when we were dealing with fractions, like here and here, how to handle that situation. Great. Now we're going to take this new skill of completing the square, and we are going to use it to help us solve quadratic equations. Okay, so we weren't solving, we were just practicing completing the square here, here, and here, so that we could use this new skill to solve quadratic equations of the form x squared plus bx plus c equals 0. So how do you solve a quadratic equation by completing the square? You can follow this quick 6-step process. Step 1, isolate the variable terms on one side of the constant. Isolate the variable terms on one side and the constant terms on the other. Step 2, find b divided by 2 squared, the number needed to complete the square. Add it to both sides of the equation. Step 3, factor the perfect square trinomial, writing it as a binomial squared on the left, and simplify by adding the terms on the right. Step 4, use the square root property. That's what we learned about last time, the square root property. Make sure to include a plus or minus symbol when you square root both sides of the equation. Step 5, simplify the radical and then solve the two resulting equations. And step 6, check the solutions. So I'm generally going to be going through the 6-step process for the coming examples, and I have a handful of examples so that we can start to get good at it. Great. So looking at this setup, we will also show you the 6-step process here as I do it. So step 1, isolate the variable terms on one side and the constant terms on the other. Well, in this case, the variable terms with x are on one side of the equation and the constant terms without x are on the other. So step 1 for this example is already completed. Yeah, okay. Now, move to step 2, find b divided by 2 squared. Now the b value, remember, it's the coefficient with the x value, the linear term. Okay, so it's positive 8. And so I'm going to take positive 8. And I'm going to divide it by 2, and I'm going to square that. And I'm going to see what I get. Right, 8 divided by 2 is 4, and 4 squared is 16. All right, I completed the square. I got 16. Cool. Now, to end step 2, I need to add it to both sides of the equation. That 16 that I got, I'm going to add it to both sides of my equation. So I get x squared plus 8x plus 16 equals 48 plus 16. Look at that. Maybe I make it red. Yeah, I just added 16 to both sides of my equation. That balances my equation. You can always add anything to both sides of an equation, and the equation is still true. All right, now that we've done that, why did we complete the square? Because we just created a perfect square trinomial. It's right here, perfect square trinomial. And you can factor it into a binomial squared. And so binomial squared of that, remember, in the binomial square, just take the b value divided by 2. 8 divided by 2, that's 4. And so that becomes the second term of the binomial. And here I'm squaring it. Great. So this perfect square trinomial right here, it factors to x plus 4 times x plus 4. In other words, x plus 4 squared. And it's now equal to 48 plus 16. I'm going to add these two constants together. And that gives me 64. Great. Now, at this point, I have completed step 3, which was to factor the perfect square trinomial, writing it as a binomial squared on the left, and simplify by adding the constant terms on the right. Yep, did that already. So I'm ready for step 4, which says use the square root property, which we used last time. So I'm going to square root both sides of this equation right here. And when I square root both sides of an equation, I need to put a plus or minus sign on the side that doesn't have the variable. That's the square root property. Now, what's great is this square and the square root die. Okay, so now I just have this binomial x plus 4, and it's equal to plus or minus the square root of 64, which is 8. Lastly, I subtract 4 from left to right, and I now have my solutions to this quadratic equation. The first solution, remember, when you have a plus or minus stacked on top of each other, that's actually 2 answers. And you could write this as a single solution, negative 4 plus or minus 8. Okay, so that's a single solution. Or you can write the solution as, what negative 4 minus 8 is, right? So you can separate this into negative 4 minus 8, which is negative 12. And then you could do the plus 8 version. Negative 4 plus 8, that's positive 4. Okay, great. So my two solutions are negative 12 and positive 4. I have solved this quadratic equation with a method called completing the square. This method of completing the square will be done in higher level math courses, and I'm helping prepare you for that moment right now. Here we go. Let's try some others. And I'm going to continue to use that step process. You can go back to refer to that in your notes. So here I go, x squared plus 4x equals negative 21, and I want to complete the square immediately. And so I look for the b value. That's the one with the linear term x. Okay, it's positive 4. So I take positive 4, here I go, and I divide it by 2 and I square it. This is completing the square. B divided by 2 squared. And that's 4 divided by 2, which is 2, and 2 squared is 4. All right, great. I completed the square. Awesome. Now what do I do with that? I take my original equation, which is x squared plus 4x equals negative 21, and I add the 4 that I just found. This 4 right here, I add it on the left side and the right side of the equal sign. Okay, I've balanced my equation. And why did I do that? Because this creates a perfect square trinomial on the left-hand side, which I can factor to a binomial squared. And what is that binomial that it factors to that's squared? Well, it's x plus 2 squared. How do I know that? Just take the b value and divide it by 2. Just like the inside of this thing, b divided by 2, 4 divided by 2 is 2. Put it right here. That's how you know. Also, this plus sign right here tells me that this will be a plus sign right here. If this was a minus sign, I would have put a minus sign right there. Great, proceeding forward, I'm going to add my constants together. Negative 21 plus 4, that gives me negative 17, doesn't it? Great. Moving on to the next step, I'm going to use the square root property, square rooting both sides of the equation and including a plus or minus symbol on the side that doesn't have the variable. Now the square and the square root fight and die on this left side, and so I just get x plus 2. And it equals plus or minus the square root of negative 17. Now remember, if you have a negative under a radical that's got an even index, this is a square root, so it's invisible, it's an index of 2, then you need to turn this into an imaginary solution. So I rewrite this as the square root of 17. Okay, but to get rid of that negative sign under that even radical, I multiply on an I afterwards. Conversely, you could have multiplied on the I in front. Some people do that. Some teachers will put the I in the front, and you could also put it at the end. It really doesn't matter as long as you don't put that I in under the radical. Don't put it under the radical with 17. It goes after the radical. It's multiplied after the radical. And to finish off this problem, my goal is to solve for x. X is right here, but 2 is added to it, so I'm going to subtract 2 to the other side like this. I'm subtracting 2, and I get my answer. X equals negative 2 plus or minus the square root of 17 times I. Now, this is two solutions, and I want to prove it to you. There's the plus version. That's the first solution. And there's the minus version. That's the second solution. If I separate my two answers with commas, it will look like this. Negative 2 plus the square root of 17 times I, comma, negative 2 minus the square root of 17 times I. We've done it. Now, we're trying to get you comfortable with imaginary solutions, right? Because there was a negative number under the square root, that produced an imaginary solution, and that's okay. We can do that. We could be okay that there's an I in there, and I, what does I equal? We've talked about this recently. I equals the square root of negative 1. That is the definition of what I is, And this algebra of imaginary numbers will be important for a lot of electrical engineers. A lot of engineering majors will use it often in the future. And, mathematics majors and computer science majors. Okay, so this becomes an important aspect of algebra. Great. Let's move on. Let's look at another one. Here I see y squared minus 18y equals negative 6. And I notice it's already set up so that you know, the variable terms are on the left-hand side and the constant is on the right-hand side of this equation. So it's already set up for me. If it's not set up like this, we would have to move things around a little bit to make it set up. But now I'm going to complete the square by looking at the b value. The b value is negative 18. And so I'm going to take negative 18 and divide it by 2 and then square that. Okay, and negative 18 divided by 2 is negative 9. And negative 9 squared, like negative 9 times negative 9, yeah, that's 81. And so I have now completed the square and I found the value of completing the square. And I add it to both sides of the equation. Let me show it to you. So I take my original equation and I add 81 to both sides, which is totally legit. I can do that. Because what I've just done is I've created a perfect square trinomial on the left-hand side of this equation, and I can factor that into a binomial squared. And so I take y and I subtract something. I'll show you what that thing is in a second, and I square it. So that's the format. And I just think of what's negative 18 divided by 2? Well, that was negative 9, right? So that's why I'm writing negative minus and then 9. So just think of what the b value divided by 2 is and write it right there. And if it's positive, well, you would put a plus. If it's negative, put a minus. But this minus sign tells me that that's going to be a minus. Okay? And so now I set that binomial squared equal to negative 6 plus 81. And negative 6 plus 81 is 75. Great. So now I have written all this stuff. Boom. This is equal to this, which is equal to this. And I'm going to use the square root property now. That's my next step. Use the square root property. Of course, I always include a plus or minus. If I square root both sides of an equation, on the side that doesn't have the variable. And yeah, this square and this square root, they fight and die. And y minus 9, it equals plus or minus the square root. Well, the square root of 75, I can expand that to the square root of 25 times the square root of 3. Here I'm using my product property of radicals. I'm splitting this radical, looking at the radicand, breaking it down into a perfect square and the leftovers. Right? 75 is 25 times 3. That's great because 25 is a perfect square. And then the square root of 25 is 5. So I get plus or minus 5, and then I'll tag on that leftovers, root 3. Great. I'm at this point, and I'm almost done solving this quadratic equation. All I have to do is add 9 from the left-hand side to the right-hand side, and I've gotten my y variable all by itself. Y equals 9, right? That positive 9, and then plus or minus 5 times the square root of 3. This is the two solutions, right? This is two solutions for y. Let me prove it to you. Because y could equal 9 plus 5 times the square root of 3. And then it could equal 9 minus 5 times the square root of 3. These are the two possible solutions for what the variable y can equal. We've done it. All right. So let's move on to a couple extra examples of me completing the square here. And we're going to, change things up just a little bit so it's not perfectly set up for you. Okay, so here when I look at example 9.15, I see x squared plus 10x plus 4 equals 15. And I want to make sure all my terms with variables are on the left side and all my constants are on the right-hand side of the equation. Therefore, I'm going to take this positive 4 and subtract it to the right side, like that. Okay, so rewriting this, I have x squared plus 10x is equal to 15 minus 4, which is 11. I'm now ready to proceed and moving on to the next step. I'm going to find the b value, which is positive 10. It's with the linear term, right? The variable to the first power. And so I take that coefficient of 10 and I divide it by 2 and I square it. And 10 divided by 2 is 5, and then 5 squared is 25. I have completed the square. And what I'll do is I will add that value to both sides of this equation that I have. So I'm adding 25 to the left side and the right side of this equation, like that. And what I've just created is a perfect square trinomial, and I can factor it to a binomial squared. So I will factor this side to a binomial squared. It's going to be x plus something squared. Okay? And what goes here? Students always ask. Well, that's b divided by 2. Whatever b divided by 2 is, 10 divided by 2 is 5. And so I put 5 right there. Okay, that's what goes there. Now 11 plus 25 is 36. And I am now prepared. Now that I have factored my perfect square trinomial into a binomial squared, I'm ready to use the square root property. So I square root both sides of this equation, and I always put the plus or minus symbol, just like you guys do now. And I'm going to cancel the square and the square root to get x plus 5 equals plus or minus the square root of 36. Well, the square root of 36 is 6. 36 is a perfect square. And next I'll subtract 5 from left to right. Okay, and I find my answer. X, the variable I was trying to solve for, it equals negative 5 plus or minus 6. And I then say, well, there are two solutions. There's the negative 5 plus 6, and there's the negative 5 minus 6. And so let's find explicitly those two solutions. In this case, we can add those numbers together, right? No radicals to simplify or anything like that. So negative 5 minus 6, that's negative 11. And negative 5 plus 6, well, that's 1. These are my two solutions, negative 11 and 1, separated by commas. We're ready to move forward into example 9.16. And let's go ahead and analyze this and see, okay, how do we set it up correctly? Well, we need all our terms with variables to be on the same side of the equal sign. So this positive 3n, I'm going to subtract it to the left-hand side to set things up for success. So here I go. I'll do it in red. Subtract 3n from right to left. I'll rewrite this as n squared minus 3n equals 11. I'm now ready to complete the square. And I need to find the b value first. Identifying the b value, that is negative 3. That's with the variable to the first power. Okay, so I take negative 3, and I divide it by 2, and I square it like this. Now, negative 3 divided by 2 comes out to, negative 1.5. I'll keep it in fraction form, like negative 3 halves here. And if I take negative 3 halves and I square it, well, take 3 and square it, and we get 9. And then take the denominator 2 and square it, and that gives us 4. And of course, a negative times a negative is a positive, so the negative's gone now. Anyway, this is b divided by 2 squared. It's 9/4. I have completed the square, and I'm going to add that value to both sides of my equation here. I have n squared minus 3n, and then 11 on the other side, and I left space to add 9/4 on the left and right hand side of this equal sign, like that. Balanced equation. Great. Now that I've done this, I have created a perfect square trinomial. This is the perfect square trinomial, and I'm going to factor it into a binomial squared because we know the patterns pretty well now. Okay, so I set it up. I have n. I have a minus sign right there, so I'm going to put a minus. And that makes sense because here I have the negative as well. Okay, and negative 3 divided by 2, this right here, that is what I put right there. So b divided by 2, right? So I put 3/2. There we go. And so you can see the negative that should be there from this, or you can look at this. It doesn't matter. You'll get it right. Now, this is all equal to 11 plus 9/4. Now, if I want to combine these into a single fraction, right, 11 can be replaced with 44/4 because 11 times 4 is 44. And so I could always take this 11 and turn it into 44/4, right? Because we know 44 divided by 4 is 11, right? Same thing, they're equal. But why would I do that? Because now I can add fractions with the same denominator. 44 plus 9 is 53, and that's divided by the common denominator of 4. Great. Now let's go ahead and have fun. To finish, I'm going to use the square root principle, right? Now that we have this binomial squared, I can take the square root of both sides here. Beautiful. And I always include that plus or minus sign. Great. And at this point, I'm going to go ahead and cancel the square and the square root and take n minus 3/2 and set it equal to. Well, does this clean up a little bit? The square root of 53? You know what? 53 is a prime number, I think. And so I don't think that the square root of 53 will clean up, but I can separate these into separate radicals, right? The square root of 53 divided by the square root of 4, and that denominator, the square root of 4, that is 2. So I can replace the square root of 4 with 2. Great. Now, the last thing I have to do is add 3/2 to the other side to solve for n. So I'm going to add 3/2 here and add 3/2 here. Okay, and then these fight and die. I've solved for n, and I'll clean it up. I'm going to write it really nice. N equals that 3/2 that I have, and then plus or minus the square root of 53 over 2. You'll notice here I have two fractions with the same denominator, so it's good measure to rewrite this all as a single fraction, okay, with the denominator of 2, and I put 3 plus or minus root 53 on top. And this is a good way to report my answer. You could rewrite both of these fractions with the plus version and a comma in the minus version to separate your answers as needed. Great. Let's look at one other format that you might see as you work on some problems. And this is the format. It's x minus 3 times x plus 5 equals 9. And when I see this, I want to FOIL these two binomials immediately. And you've practiced that skill. You're pretty good at it. So here we're going to practice foiling. Let's multiply the first terms together. X times x is x squared. And x times 5 is positive 5x. And x times negative 3 is negative 3x. And negative 3 times 5 is negative 15. And we are now at this spot right here. It equals 9. And my goal is to get all of the terms with the variable on one side and all the constants on the other. So I'm going to add the constant 15 from left to right. And I'm also going to combine these like terms. These are like terms right there and there. And so cleaning it all up, I get x squared, and 5x minus 3x is positive 2x, and that equals 9 plus 15, which is 24. Okay, so I'm at this point. I've cleaned it all up, and I'm ready to begin my process of completing the square. So I ask myself, what's the b value? And the b value is positive 2. All right, so I'm going to take the b value of positive 2. I'm going to divide it by 2, and then I'm going to square it, because that's what we do to complete the square. We take the b value divided by 2 squared. And 2 divided by 2 is 1, and 1 squared is 1. Okay, I've completed the square. I'm now going to rewrite my equation. Adding 1 Yes, this value that I just found, I'm going to add it to both sides of the equation. Now, this is a perfect square trinomial. I will factor it into a binomial squared. And so I get x plus 1 squared. And how did I get that? Well, I started the binomial with x, because x times itself will give me x squared. And then this plus sign tells me, hey, I need a plus sign there. And then I look at this, a b divided by 2. b divided by 2 is 2 divided by 2, which is 1. That's what I put here. Now, I take 24 plus 1 to get 25. And I'm done with my factoring of the perfect square trinomial into a binomial squared. Why did I do that? So that I could take the square root of both sides like this, and I would never forget the plus or minus symbol, because this is the square root property. And squaring and square rooting fights and dies, and I get x plus 1 equals plus or minus 5. The square root of 25 is 5. And so I finish by subtracting 1 from both sides. There it is, right? Because this plus 1 and this minus 1 cancel. And I now write my solution. X equals negative 1 plus or minus 5. Yep, I decided to put that negative 1 first and that plus or minus 5 second. That's good. And in this case, I can go further and I can decide to find each solution taking negative 1 minus 5, which gives me negative 6. I put a comma, and now I take negative 1 plus 5, and that gives me a value of 4. And these are my two solutions for x. Done. All right, everybody. Now, how can we increase the complexity of this process, you may be asking at this point, and that's a great question. We can increase the complexity of this by introducing an a value, the value that is with x squared, and we can increase it from what we had as 1 for every single one of these examples so far to a higher value than 1, like 3 or 2, yeah? So that's how we can change things up. And if that a value is increased to something greater than 1, then we have just a couple extra little things to do. Really, it's just one extra thing to do. So we introduce something new in step 1, and that is to divide by a to make the coefficient of x squared term 1. Okay, so whatever the a value is, divide it from the entire equation, and then you can proceed. Great. Then every other step is exactly the same. Not so bad. Isolate the variable terms on one side and the constant terms on the other. Great. We did that before. Find b divided by 2 squared, the number needed to complete the square, and add it to both sides of the equation. Yep. Factor the perfect square trinomial, writing it as a binomial squared on the left, and simplify by adding the terms on the right. Yep. Step 5, use the square root property. Yep, done that. Step 6, simplify the radical and then solve the two resulting equations. And step 7, check your solutions. Great, let's try it out. Everybody, I'm going to take this entire equation, both sides of the equation, and I'm going to divide it by the a value, which is 3. And I'm going to rewrite the equation. And now my a value is gone. It's just, because 3, let's do it one at a time. 3x squared divided by 3 is just x squared. Right? And then negative 12x divided by 3 is negative 4x. And then negative 15 divided by 3 is negative 5. And that equals 0 divided by 3, which is 0. Okay, but we still have to complete the square. So before I can do that, I have to add the constant to the other side to get all my variable terms on one side of the equal sign and my constant on the other. All right, I'll rewrite this just for funsies. X squared minus 4x equals 5. I'm now ready to complete the square, so I look at the b value, it's negative 4. I take negative 4. I divide it by 2 and I square it. And negative 4 divided by 2 is negative 2, and negative 2 squared is 4. Now that I completed the square, I'm going to add it to both sides of my equation, that value that I just found. So let me do that. I'm going to create a little space here so it looks nice and clean. And I have a plus 4 here and a plus 4 here. I balanced my equation with the value of completing the square. Boom, deek, deek. So now here on the left, I have a perfect square trinomial, which always factors to a binomial squared. And that binomial squared is x, and I'm going to have a minus sign, and I have that binomial squared. So I set it all up with all the right stuff. And how do I find this? Take the b value divided by 2. Just the stuff in parentheses here. Don't worry about the square. Negative 4 divided by 2 is negative 2. And so that's why I get this minus 2 in that binomial. I hope it all makes sense now that we've gone through it multiple times, but 5 plus 4 is 9. So I put 9 there, and I'm now ready to apply the square root principle. When I apply the square root principle, I always include the plus or minus sign, and the square and the square root fight and die here, and I get x minus 2 is equal to plus or minus 3, because the square root of 9 is 3. All right, and lastly, I'm going to add 2 from left to right so that I can get my variable x by itself, and I find out x equals 2 plus or minus 3. And that breaks down to two separate solutions, 2 minus 3 and 2 plus 3. 2 minus 3 is negative 1. 2 plus 3 is 5. And these are my two solutions. Great. Let's try that process again. I look at this example and I say, oh man, my a value is 2. It's not 1. So I have a very first step to take. I'm going to divide the entire equation by the a value. Okay? So I divide by 2, like that. And now I clean it up and I say, well, 2x squared divided by 2, that's 1x squared. And negative 3x divided by 2, well, that doesn't clean up so easily, so I'm going to put negative 3 halves times x. And then that's equal to 20 divided by 2, which is 10. Perfect. So I now have things set up, this cleaned up nicely. I have all my variable terms on the left-hand side and the constant terms on the right-hand side of this equation. And so now I'm going to look for the b value. The b value is negative 3 halves. And so I take negative 3 halves and I divide it by 2 and then I square it like that. Now to help you, when you take like negative 3 halves and divide it by 2, you can multiply 2 times 2 to get a new denominator of 4. It's this crazy thing. So this becomes, let me set this up. This becomes negative 3/4 squared. So you could think of it like that. Remember, 3 halves divided by 2 is 3/4. Okay. You could also input this into your TI-30XS calculator, which is your approved calculator for this course. And then let's go ahead and take 3 and square it. So numerator squared is 9. And take the denominator 4 and square it, and we get 16. And of course, a negative multiplied by itself makes a positive. So yeah, when you square a negative number, the result is positive. I got 9/16 when I completed the square. And so now what I do is I write my equation how I had it before. All the same stuff. But I add on 9/16 on the left and right hand side of the equation. I'm adding it to both sides. Great. Why have I done what I just did? Because that created a perfect square trinomial, and that perfect square trinomial factors to x minus something squared. Okay, and what is that thing that goes right here? Well, it's b divided by 2, right? This b divided by 2, and that is the negative 3/4. I already put the minus sign for the negative, and so I now put 3/4 here. Awesome. Well, next I'm going to add 10 plus 9/16, and I'll show you a cool way to get it done. See, 10 is 160/16. Yeah, so take 10, multiply it by 16, and you get 160. So 10, I'm going to replace it with 160/16. Why would I do something like that? so that I can add these two fractions together because now they have the same denominator. And 160 plus 9 is 169. And I'm dividing that by the common denominator of 16. Great. So that's a cool trick. Yeah, you learned it from me here. And now I'm going to use the square root property, square rooting both sides of this equation, and of course, including the plus or minus sign. And so now I get x minus 3/4. It's equal to plus or minus. Well, the square root of 169 divided by 16, the crazy thing is 169 is a perfect square, and 16 is a perfect square. And so this cleans up because the square root of 169 is 13. You guys know your perfect squares pretty well now. And the square root of 16 is 4. All right, last thing to do, add 3/4 from one side to the other so that you can get x, the variable x, by itself. And writing my solution, I get x equals 3/4 plus or minus, well, 13/4. And you'll notice, hey, we've got the same denominator here, and there's no radicals or anything like that anymore, so I can take this and add it with this and take this and subtract this to get my explicit answers for x. In fact, you know, if I take 3/4 and I subtract 13/4, that gives me negative 10/4. Yeah, because 3 minus 13 is negative 10. And then if I take 3/4 and I add 13/4, that gives me 16/4, like that. 3 plus 13 is 16. But 16 divided by 4 simplifies. 16 divided by 4 is 4. So there you go. My two solutions are negative 10/4 and 4. All right, let's try this one more time for good measure. Congrats if you're still sticking around for this. I see this example that says 3 times x squared plus 2x equals 4, and I decide to divide by the a value on both sides of the equation. I divide everything by the a value, and 3x squared divided by 3 is x squared. And 2x divided by 3 is 2/3 x. And that's equal to 4 divided by 3, which stays 4 divided by 3. Let's go ahead and look at the b value. The b value is positive 2/3. So I take the b value, 2/3. I divide that by 2, and I square it. All right. If you take 2/3 divided by 2, that gives you 2/6. What did I just do? I multiplied 3 times 2 to get a new denominator, 6. And that's squared. And when you have a fraction that's squared, you can square the numerator. 2 squared is 4. And then square the denominator. 6 squared is 36. Great. We've completed the square. This is the value, 4 over 36. If you want to, we could reduce it, right? Like 4 over 36, that's reducible. If I divide the top and bottom by 4, I get 1 over 9. So I'll use 1/9. Great. So I'm going to go over here. I'm going to add 1/9 to the left side and the right side of the equation, like that. I've created a perfect square trinomial, which always factors to a binomial squared. Here's my binomial squared. I'm setting up for it. What goes here? Well, that's b divided by 2. 2/3 divided by 2, which turned out to be 2/6. And I could even reduce that piece right there. 2/6 reduces to 1/3. So I'll put 1/3, making my life easier by reducing my fractions. At this point, I see 4/3 plus 1/9, and I want to add them together to get a single value. So I think to myself, how can I turn this into a certain amount of ninths? And I could do it by multiplying 3 on top and bottom. Okay, let me show you explicitly. I'm going to multiply 3 to the top and bottom. That way I can have the same denominator. And 3 times 4, that's 12. And 3 times 3, that's 9. Now I have 12/9 plus 1/9. That gives me 13/9. There you go. Now that I'm to this point, I've factored my perfect square trinomial into a binomial squared, and I can use the square root property. Applying the square root property helps the square and the square root fight and die. And now I just have the x plus 1/3, and it equals plus or minus the square root of 13 divided by the square root of 9. And 9 is a perfect square, so the square root of 9 is easy. It's 3. So I'm going to just turn that into 3. And I'm now going to subtract 1/3 from the left side to the right side because we are trying to solve for x. And I find out that x is equal to, well, negative 1/3 plus or minus the square root of 13 over 3. I've got two solutions. Remember, whenever you have a plus or minus symbol stacked on top of each other, that's actually two things written in one. So this plus or minus sign, you know, one thing that I would do in this case, since I see the same denominator of 3, is combine the two fractions into a single fraction. So that denominator of 3 is there, and on top I'll put negative 1 plus or minus the square root of 13. This is a great way to report my answer. Okay. Of course, you could separate this into two answers, this with a plus sign and this with a minus sign with a comma between. That's whatever the problem asks you to report your answer as, that's what I recommend. Anyway, hey, great job. We have just done a lesson practicing our completing the square skills, which is a great method that helps us solve quadratic equations, which is what this chapter is all about. I hope you all have a wonderful day. Thank you very much, and take care.